welcome to educlub for you, and this is another video related to the remainders. And in this video we try to find out the answer of some complex question where you need some theorems to find out the answer, and every time you need some creativity for that also. So let us try for this video. But before that, again I like to request all of you to subscribe this channel, inspiring us and give us the power to make some more videos. Okay, so let us start this video. So first we move forward to a question that when 19 factorial is divided by 343. Okay, I write down that question. Let us solve the question is 19 factorial divided by 343. Okay, you make a pause right now and think about it, that how you can solve this one very comfortably. Okay, otherwise I will make some ideas for all of you to try to find out in this way also. Okay, now see, 19 factorial means we are having from 19 to 1, and 343 is at all not a prime number, it is a cubic number, it is 7 to the power 3. Okay, so if I write down this one, this is simply 19 up to 1 divided by 7 cube. This is the questions that we have. So 7 cube means 3 number of 7s are multiplied together. And from the series 1 to 19, we having two multiples of 7. One is 14, another is 7. First one is 7 1 is 7, and second one is 7 2 is 14. So here 7 and 14, as both are the multiple of 7, in this case we take 7 square as the common factor. Okay, just like the previous questions. So here 7 square and 7 square, this is the common factor we having. Now what is the remaining? Now from 1 to 6, what we are having, from 19 to up to 15, you left 14 right now. Then again from 13 to 8, again from 6 to 1. We left two things, one is 7 and another is 14. 7 2s are. Here we are having 2. You keep it in mind. That otherwise I can write down that one also. Instead of 14, I can write here as 2, because I am taking 7 as a common factor. Clear? Now, so here that divided by 7, because total we are having 7 cube. Common factor is 7 square. So the remaining one is 7. When 7 divided by 15, remainder is 7 2s are 14, remainder is 1. 7 divided by 16, remainder is 2, remainder is 3, remainder is 4. Like that, when 7 divided by 19 divided by 7, so 7 2s are 14, so remainder is 5. So here from 1 to 5, this is 5 factorial. Again from 8 to 13, again remainder is 1, 2, 3, 4, 5, again 5 factorial. And now from here 1 to 6, we are having 6 factorial. So what we are having here, from 19 to 15, we are having 5 factorial. Then from 8 to 13, we are having 6 factorial. These are the remainders. Again 1 to 6, 6 factorial. And overall we are having 2. This 2 is for 14. Clear? So all total this is 6 factorial square into 5 factorial into 2 divided by 7. Okay, now I can write down this one as 5 factorial into 6 factorial square into 2 divided by 7. Now 6 factorial, 720, we are having, if you take the multiple of 7, 721, one of the multiple of 7. So here we are having what? Minus 1 square, that equals to plus 1. 5 factorial, that equals to 120. I can write down this one also, that you can find out all those things mentally, but for explanation I just write down those things. This is 5 factorial means 120, this is 720 square, this is 2 divided by 7. Now 119 is a multiple of 7, so here the remainder is 1. 721 is a multiple of 7, here minus 1 square, again 1, and finally 2 divided by 7. So totally we are having 2 divided by 7, so remainder is 2. So here 2 divided by 7, remainder is 2. And the common factor is what we are having? 7 square. Remainder here is 2. So final remainder is 7 square into 2. Final remainder 49 into 2, that equals to 98. This is the final answer that we have. Okay. So let us try another example. Now question is 36 to the power 45 divided by 49. So this 36 to the power 45, 36 is at all not a prime number. So 36 can be expressed as 6 square. So here we are having 6 square to the power 45. So that equals to 6 to the power 90. So the same thing can be written as 6 to the power 90 divided by 49. Okay. Now this 6 to the power 90 when divided by 49, if you take the powers of 6, the results never be very close to 49. Okay. So for that we need some different type of ideas to find out the answer. You make a pause and try to think about it, that how we can solve this one. Okay. If you try it by yourself, it is quite good. Otherwise, I'll solve it for you. Okay. Now 6 to the power 90 divided by 49 can be written as 6. We know that 7 power is 49. So here 6 can be written as 7 minus 1. So 6 to the power 90 can be written as 7 minus 1 to the power 90 divided by 49. Okay. Now this 7 minus 1 to the power 99, by binomial expansion we can write down this in that expansion way. I'll give you the idea. This is 7 to the power 90, then plus 90C1, 7 to the power 89 into minus 1 to the power 1. Again, in this way you can write down till the end. And finally, what we have? We have minus 1 to the power 90. Just before that, 90C 89, 7 to the power here 1 and minus 1 to the power 89. Before that, we are having 90C 88, 7 to the power 2 minus 1 to the power 88, and so on, so on. 89 is 7 square. So 7 to the power 90 must be divisible by 49. Or 7 to the power 89 we are having divisible by 49. 7 to the power 88, 7 to the power 87, 7 to the power 86, and so on, so on. Every part is completely divisible by 7 square. Up to the third term, from the end, because we are having only 7 to the power 1 here. Last one we are not having anything as 7. Simply minus 1 to the power 90, which one is plus 1. Just before that we are having 7 to the power 1, and before that 7 to the power 2. Now here we are having 7 to the power 2. Here also we are having 7 to the power 2. So up to this much, every term is completely divisible by 7 to the power 2. The only last two terms are not divisible. So we should concentrate on the last two terms only in this expansion. Okay, now the last two terms, last one is minus 1 to the power 90, that equals to plus 1. Clear? Now just the previous one is 90C 89, that equals to 90C1, means this is simply 90. 7 to the power 1 means 7, and minus 1 to the power 89 means minus 1. Every previous term is divisible by 7 square, so we don't need to write down this one. Only these two things are required. This divided by 7 square or 49. Now this is 90 into 7 into minus 1. So this is minus 630 plus 1 divided by 49, or minus 629 divided by 49. Okay. So minus 629, you can subtract 490 from that. Okay. Now what we are having? If you add 10, this is 500. 129 plus 10, 139. Now 139 divided by, this is minus 139 divided by 49. I am trying to find out everything mentally. If you use paper and pen, it is a little bit, you need extra time for that. Okay. So 49 threes are what we are having, 120 plus 27. So 120 plus 27 means 1 minus 8. So final remainder is 49 minus 8, 41. This is the final remainder in this question. Okay. Now let us try another example. In this question, we are having 15 factorial divided by 34, and we have to find out the remainder. Okay. So here we need a theorem, a Wilson theorem, that give you the idea that p minus 1 factorial when divided by p, it always gives you a remainder of minus 1. Okay. So I try to use that theorem to find out the answer here. So this 15 factorial means we can write down that 34 is, this is also not a prime number. This is a composite number, that is 17 into 2. So I am using for 17. We can write down here 17 minus 1 factorial when divided by 17, that gives you the remainder of minus 1. Okay, this is as per the Wilson theorem. So this 17 minus 1 factorial, let us suppose 16 factorial divided by 17. Let's suppose x is the quotient you are having. Here this is minus 1. Minus 1 means 17 minus 1, that equals to 16 also. If you write down this one minus 1, this is similar to 16. Okay. So how this 16 factorial can be expressed? Here that 16 factorial equals to 17x plus 16. Isn't it? 17 into x means divisor into quotient plus remainder equals to dividend. 16 factorial equals to 17 into x, remainder is minus 1, that means 16. So plus 16. Okay. Now here if, but we are having the target 15 factorial. So if I divide 16 on both the side, right side and left side, then we'll take 15 factorial. We'll get 15 factorial. Now divided by 16, here also divided by 16. Means here 15 factorial can be expressed as 16 is completely divisible by 16. Okay. Now this part is what? This is 17 into x plus 1. When I divide it, 17 into x means I'll take here as x1. x1 is what? Anything which is a multiple of 16. Because 16 and 17 both are consecutive. When two numbers are consecutive, they are always co-prime. So if anything is 16 into something and that divided by 16, means this x must be divided by 16. Okay, now, so the value of this x in the form of, let us suppose y or x1 or whatever, plus 1. Now, this 15 factorial must give you the result 0 at the end. 5 factorial onwards, any factorial, the unit digit is always 0. So this 15 factorial always having the unit digit 0. Now finally here we are having 1. So this value must be an odd number, because as this one is even, so this must be odd, because 1 is again odd. Now, this x1 now can be expressed as, if anything is odd, this is in the form of 2n plus 1. That may be 2 to the power 0 plus 1 or 2 to the power 1 plus 1 or 2, anything. So 2n plus 1, this in the form of 2n plus 1. I can write down this one as 17 into 2n plus 1 plus 1 equals to 50 factorial. Okay, now 17 into 2 means 34n. 34n plus 17 plus 1 divided by whatever, that equals to 15 factorial. Now this is 34n plus 17 plus 1 means 80. 34n plus 80. Now in this questions what we are having? 15 factorial divided by 34. Means if 15 factorial can be expressed in this way, and when 15 factorial divided by 34, this must be divided by 34. 34 into n, if divided by 34, that give you the remainder 0. Now what are remaining? 17 plus 1, 18. So here this is completely divisible. 18 divided 34. So final remainder 18. This is a different way to find out the result. Okay. Now we'll try the last example. Now the question is 1 factorial square, 2 factorial square, 3 factorial square up to 50 factorial square divided by 1152. This is the question that we have. Now 1152 is again, it's not a prime number. So we have to find out that 1152 is how we can express it in prime with power n. 1152 can be expressed as 2 to the power 7 into 3 to the power 2. Means 128 into 9. 1152 can be expressed as 128 into 9. 2 to the power 7 and 3 to the power 2. So here we try to find out where we can get 2 to the power 7 or more than of. Let us suppose 2 factorial square. 2 factorial having only one number of 2. Square means we are getting 2 number of 2. 3 factorial square having the same value. 4 factorial square. 4 factorial means what we are having? 4 factorial means 1 into 2 into 3 into 4. So here we are having 1 and here we are having 2. So total we are having 3. Means it is divisible by 2 to the power 3. And square means 2 to the power 6. So this is not enough. Now 5 also give you the same. 5 factorial is divisible by 2 to the power 6. But we need 2 to the power 7. So if you consider up to 6 means 6 factorial means into 5 into 6. So 6 will give you another 2. Okay, now so here we are having 2, 2, 2 and again 2. This from here, this 2 are from there, and here. Total 6 factorial having 4 number of 2's. If you make a square of this, then that will produce 2 to the power 8. Means 6 factorial square is completely divisible by 2 to the power 8. So any onwards number, 7 factorial square, 8 factorial square, 9 factorial square, 10 factorial square, up to 50 factorial square, every number is completely divisible by, yes, 2 to the power 7. Now, in case of 3 square, 3 square means here 3 factorial square. 3 factorial having one number of 3. Square means we are getting 2. So every number onwards 3 factorial square is completely divisible by 3 factorial square. Means 3 to the power 2. So if you consider till, I just write down, up to 5 factorial square, then it is not completely divisible by 2 to the power 7 and 3 to the power 2. Because up to 5 square, we are having 2 to the power 6, not 2 to the power 7. And from 6 factorial square to up to 50 factorial square, every time we are having 2 to the power 7 or more than of that, we are having 3 to the power 2 or more than of that. So we don't need to worry about all those numbers. Only we need is what? 1 factorial square, 2 factorial square, 3 factorial means 6 square 36, 4 factorial 24, 5 76 and 5 14400. This divided by 2 to the power 7 and 3 to the power 2. 6 factorial square and onwards, every number is completely divisible by 2 to the power 7 and 3 to the power 2. So you just need to find out the sum of this result and that divided by 1152. So here the sum is what you are having. Let us suppose this is 40, 41. If you add 41, this is 7, 1, 6, 7, 1, 0, 5, 1. 15017, 15017 divided by 1152. So whatever that may be, that one is the remainder in this case. So if you divide this one by using pen and paper, finally you get 41 as the remainder. But one more method is also there, that if you consider 3 square, then remainder is what? From 3 factorial onwards, everything is divisible. For this 2, we are having remainder 5. And for 2 to the power 7, up to 5 factorial, remainder must be 41. So you find out such a number in the form of 3 square means 9x plus 5. And here 128y plus 41. You find out that number, divided it with 1152, you will get the result. But this is comparatively easier. Okay. Now, in this end of the remainder theorem, now I'll give you some challenging question and you kindly accept this challenge and try to find out the answers. In the link given below, I'm providing you the answers and its explanations also. Pride, be the master in remainders. Keep watching our video. Thank you.